Hi, it's Mr. T here with my second video on organic chemistry. This is for beginning organic chemistry, level 2 NCEA. And in this video, we're going to look at how to name alkenes and alkynes. And we'll look at something also called geometric isomerism. Okay, so an alkene is a molecule that has a double bond in it. So the carbon forms two sharing bonds. So there are 4 electrons or 2 pairs in between these 2 carbon atoms here. Because it has 2 bonds, it's got the potential for 1 bond to break, and you could potentially add 2 more hydrogens. Because of that, the molecule is commonly called unsaturated or classified as unsaturated. That is, more hydrogens could be added, so it isn't saturated with hydrogens yet. So this is called an unsaturated hydrocarbon because it contains only carbons and hydrogen, but it has a double bond. When we want to name alkenes, we use the suffix or the end of the name "-ene" instead of "-ane". So the number of the closest carbon to the double bond goes just before the "-ene". Let's look at an example of this. So here is our molecule. Now the first thing we do is the same as we did with the alkanes. We identify what type of molecule, what group of molecules it is. And for this one, there is a double bond, so we know it's an alkene. And that means the end of its name is going to have an "-ene". We identify the longest chain in the molecule, 1, 2, 3, 4, 5. So this is an "-ene" on the end, but there are 5, so it's going to be called pentene. But up here we said that we place a number to say where the double bond is before the "-ene". Now before we do that, we need to recognize that this double bond is very important, and it's even more important than this group here, okay, this substituent group that I wrongly called a functional group here. Oh, sorry, the alkyl functional group is more important and it gets a number, so I'm going to go 1, 2, 3, 4, 5. So the actual smallest number of the double bond is number 2, and that's the one we use. So we're now going, and remember we had this substituent or this methyl group up here off number 4. So the name of this is 4-methyl-pent-2-ene. Notice I've put this name called trans in front of it. Sometimes alkenes have another part of the name that goes in the front that says whether it is has an arrangement that is across the double bond like this, that is called trans, or through the double bond like this, that is called cis. But we'll look at that in the next slide. So when we have a trans or a cis version of a molecule, they are called stereoisomers or geometric isomers. Geometric isomers because they have different geometries. Even though they're attached to the same numbered carbons, they are pointing in a different direction or a different geometry. So here are 2 molecules that we would call both them pent-2-ene. We would call them but-2-ene. Okay, so they would both be called but-2-ene. But notice both of them have a double bond in the middle. Now the double bond does something quite interesting. So if you can think about it, if I have a single bond joining 2 molecules together, they can rotate. We have to believe that the single bond between carbons allows it to rotate like this. But as soon as we put 2 connections there, they can no longer cross each other and they can't bend. So imagine if my hands, right, there they are there. So if I had a double bond, then my other fingers are stuck at the bottom. This would be a cis arrangement. If I had the molecule like that, I'm trying to be a bit of a contortionist here, then that would be a trans arrangement. Now the reason we get caught in opposite or the same side, cis or trans, is because of this double bond. If it was a single bond, they can just spin whenever they want to and they never get caught on the same side or different sides. So because this has a double bond, this one is called a cis butene, and because this has a double bond and they're across, this one's called a trans butene. On the same side, cis. the same, cis across trans. Now, in order to actually be a set of geometric isomers, or to be able to be geometric isomers, you have to have two things. You have to have a double bond. Check. There is a double bond present here. And you have to have two different groups or atoms off either side of the double bond. So I look on the left-hand side of the double bond, I have a group of CH3 and a hydrogen. These two are different, so therefore it meets the requirements of the second point. On the right-hand side, a CH3 and a hydrogen, they are different, so it meets the requirements. This will form a geometric isomer. There will be two versions. One when the CH3s are on the same side, cis, and one where the CH3s are across on different sides, trans. Just a wee note here, this is actually cis-butene and trans-butene, but I don't have to include the two because the only type of butene that can be a geometric isomer is a cis. But1ene cannot be a geometric isomer because one of the carbons of the double bond, it will have two groups that are the same and it won't meet the requirement of point 2 here. Okay, let's look to name a couple of examples. So the first example we've got here is this molecule here. The first thing we notice about the molecule is that it's got a double bond carbon, so therefore it's going to be an alkene. The next thing we can see is that there are 4 carbons in the longest chain, so it's going to be butene. But we've got the number 1, 2, 3, 4. The double bond comes off the second carbon, that's the smallest number, attached to the carbon with a double bond, so it's going to be but2ene. And then the last thing we notice is there's 2 groups up here, so let me just put this pointer on laser pointer. We have 2 methyl groups, so we're going to call this 2,3 dimethyl but2ene. And the next example we have is this one here. Again, we see that we've got a chain here of 5 carbons. There is a double bond, so this is going to be a pentene. It comes off the second carbon, so this is pent2ene. But now we also see there are 2 functional groups. There are 2 chlorofunctional groups, 2 chlorines added to this molecule, and they're coming off the second and the third. And the last thing we can see is because this is a double bond, and each side of this double bond we have 2 separate groups attached to that carbon and 2 separate groups attached to the carbon on the other side, or atoms or groups, we can see this as a geometric isomer. And the actual geometric isomer this is it is trans because they're found across the double bond. So this one here is going to be called trans 2,3-dichloropent2ene. Okay, the last slide here we're going to look at alkynes. Alkynes are very similar to alkenes, but they're different because they have a triple bond instead of a double bond. They're instead of called alkenes, they're called alkynes, and their name changes in the same way. So YNE is the end of the name instead of ENE. Let's have a look at this example here. The longest chain is 5. It has the triple bond coming off the second carbon, so it is going to be called pent2ine. Ine means triple bond. The last example here is there are 4 carbons in a row. The triple bond comes off the first carbon, and there is a methyl group coming off the third carbon. So this one is going to be called 3-methyl but1ine, and that's how we name triple bonds. Well, I hope this video has been useful. Look out for the next video where we will look at haloalkanes, and I'll see you then.